Hi folks, welcome to section 8.2, confidence intervals for a population mean mu when sigma is unknown or simply not given. We might ask why. Well, we are attempting to make an educated guess about an unknown population mean mu based on our sample. In this scenario, why would we mysteriously know what the population standard deviation, sigma, is? So how do we modify what we did in 8.1 to accommodate not knowing what sigma is? So our assumptions, like before, the original population is normally distributed, or we have that large enough sample size and greater than 30. That's our central limit stuff. And then we have this new assumption that we have a simple random sample. If you go back to 8.1, that wasn't there. I'm not going to make a big deal out of these assumptions, but if you like to know about these things, that's a new assumption. All right, so first vocabulary, X bar, our sample mean, is still our point estimate. All right, that one number, remember that's our dart that we're going to throw at the tiny dot, that's the population mean. And here's our old margin of error formula. E equals z alpha over 2 times sigma over the square root of n. That was what we used in 8.1. But now we have no more sigma. So we have no way to use the normal distribution on the calculator. For example, how do we put a sigma in? How do we move forward? So here we go. Instead of sigma, we're going to use S, the sample standard deviation, as we'll have our sample. And then instead of z alpha over 2, we're going to use something new called t alpha over 2. So what is this? It'll take me a little bit to explain it. But in any case, here is our new modified margin of error formula for this section. Still E, but it's going to be t alpha over 2 notation times s over the square root of n. So it's the same structure, just with this new t thing and with s. All right, so we need to talk a little bit about this thing called the t distribution, sometimes called the student t distribution. So here's a picture of the t distribution. If you think it looks a little bit like my normal distribution graphs, you're absolutely right. I'm just going to put a t right here next to the horizontal axis, and that's going to make it the t distribution. It does look like a normal distribution. It does have a mean of 0, so 0 is still going to go in the middle there, and it is symmetric, highest in the middle. But there's no standard deviation, no sigma. Instead, there is this new thing called degrees of freedom. And the little formula for this, df, degrees of freedom, is n minus 1. So we're going to need to keep track of that. All right, and then we're going to find critical values. We're going to have confidence levels and tail alpha areas and all that stuff again. And to find critical values, we're either going to use a t-table, and this is posted in Canvas. So hang on a bit and see if you can do this on your calculator. And if you don't have this in your calculator, you'll use the t-table. And it's actually a pretty easy table to use, and I'll explain it here. But on the newer calculators, see if you've got it. Go to second vars, as though you're going to normal CDF or inverse norm, and see if you've got something called inverse t right underneath inverse norm. And the things we'll put into it are, like inverse norm, the left area, and then this one new thing, the degrees of freedom. So over here on the left, I've got a picture of what it looks like, inverse t. If you can find it, you might put those numbers in and see what you come up with. And when I run this, just to practice if you want, I get a t-value, not a z-score anymore, but a t-value of negative 2.015 ... Again, these long numbers that come out of the calculator. So you might give that a try just to see if you can get that function to work. If you do want to give the t-table a try, go and get it. And then you'll notice, if you look at it across the top, there is an area to the right. So we would look up that area, 0.05 across the top, and then down the left-hand side, you'll see the columns are the degrees of freedom. So degrees of freedom, this example I had 5. So you'll find 0.05 across the top, 5 down the left-hand side, and where those two numbers meet in the table is our answer, and I get 2.015. And the table always gives the positive version, whereas our calculator typically gives us that negative version. Then, while we're talking about the calculator, here's how we'll get our intervals on the calculator. You're going to go into Stat and Tests. Remember where we were doing Z interval before. So the Stat button, Tests menu, and now you're going to go to T interval. You probably have to scroll down to find it. This is what it looks like, very much like the Z interval, so you have to be careful you're in the right place. And you'll see there's spots for the mean, the sample mean, the sample standard deviation, our sample size, and our confidence level. And this is in fact the numbers for our first example down below, so I'll refer back to this in just a moment. So before we get to an actual interval problem, let's just try a couple of critical value problems. So these are on page 385 of the book, number 12. And notice the notation. Find the critical value t. So that's a big clue that we're in the t distribution. We're just doing the critical values. So we're going to draw our same pictures and then either use the calculator or the t-table to get our answers. So confidence level of 90%. I'm going to draw my drawing that looks just like a normal distribution, but now it's a t distribution. 0, always in the middle. And I want 90% confidence level. That means I'm going to put the middle 90% area, mark that off. So 90% in the middle, which is 0.9. Okay, so that idea is still true. And then once again, we have this alpha, the leftovers being the total in both tails. So alpha is the 10% or the 0.01 in both tails. So once again, we have 0.01 over 2 in the left tail to be our alpha over 2 amount, and the same amount in the right tail, alpha over 2. It's 0.01 over 2. Oops, I did that wrong, didn't I? So 0.1 over 2. Sorry, I don't think I can go back and do this all over again. So 0.10 over 2, 0.10 over 2 in each of those tails, and that's 0.05. Okay. So then we're going to look for a t alpha over 2 value that's positive on the right side of 0, and we'll have a matching negative t value on the left side of 0. T sub alpha over 2. I write it wrong sometimes myself. Okay, so here we go. On the table first, I guess. Oops, I meant to go to blue. The t-table, right? You're going to find the area of that one tail, the area, 0.05 across the top. So when we find the area in the table, you'll notice that there's actually 2 rows at the top for area. And so at the top row is area in one tail. So you could look up 0.05 in one tail, and that's going to be the same as 0.10 in 2 tails. Right? That's really saying the same thing. It's the same column on the table. So that's the column we want to be in. And then we have a sample size of 6. So when n is equal to 6, that means our degrees of freedom is equal to 5. So then the table gives, if you look where the 0.05 or the 0.1 at the top, intersects with degrees of freedom 5, we get that 2.015. And that's exactly what we did on our calculator just a few moments ago. So that's our T alpha over 2 value. Let me put an equals in there. Maybe that's just as good. And if you want to try once again with the calculator, that would be inverse T, right, in the second VARS area. Sorry, my writing. I'm still learning how to do this. Inverse T, we would put in that left area of 0.05, and then just our degrees of freedom, those same two numbers. So we have an area and a degrees of freedom. And the calculator gives the negative value because the calculator thinks you're putting in the left area in particular. All right, so that's our critical values. This would be the negative 2.015, and this T value on the right would be positive 2.015. Okay, let's try another example. Confidence level of 98%, sample size 12. All right, so draw your picture. Okay, 0 in the middle. T is our label on the horizontal axis. Pretty much the same picture. Now we have 98% or 0.98 in the middle. Figure out what that leaves for the tails. So alpha in those two tails, it would be the 0.02. And so then alpha over 2 would be 0.01 in each of the individual tails. Okay, so then go to your t-table with either the 0.01 in one tail or the 0.02 in two tails. And again, you'll see that that is going to refer to the same exact column. And then the degrees of freedom is 1 less than the sample size, 12 minus 1, is equal to 11. All right, so the degrees of freedom 11, look up the area. In the meantime, those of us using the calculator, inverse norm, bad. Inverse T of that left area, 0.01, degrees of freedom 11. And the calculator gives me the negative, again, as always, negative 2.718. The t-table would give me positive 2.718, right? So it's the same number, just positive versus negative, and that's exactly these two numbers on the horizontal axis. Positive T alpha over 2 is 2.718, and negative T alpha over 2 is negative 2.718. Okay, and that's the end of part 1. We'll see you in part 2.